last time.
Okay.
Is it going?
Mm-hmm.
So, who remembers the last two lessons? Because this is lesson 3. Anybody remember the last 2 lessons? What's the first lesson?
What a computer does, how it inputs something, stores it. Well, not stores it. Like processes it, stores it, and then outputs it.
Good. What's the other lesson?
Ones and zeros.
Yeah. Okay. Cool. On and on.
Binary systems.
Yeah. Alright. So this is the continuation of the last lesson. We're gonna talk about some stuff. So yeah, we're gonna continue. So your essential questions is by the end of this lesson, you'll know what a transistor is. You'll know what binary is, like fully understand binary, and you'll know how to count in binary, right? So this is how do computers represent data, lesson 2, but it's the 3rd lesson, right? But it's part 2 of last lesson. Okay, so and then your objectives is I will know what a transistor is, and I'll know what binary is, and I'll know how to count in binary. So who knows what a transistor is? Anybody know what a transistor is?
No.
Transistor is
You know what a transistor?
a group of electric circuits.
Yeah, something like that.
Yeah.
We're not going to go into detail. Okay, so what is a transistor? Well, this is kind of like a footnote. So in 1947, engineers invented the transistor, right? A transistor is a tiny physical device that acts like a digital switch in computers, right? So a transistor turns on when there's enough electricity that flows through it, and then it turns off if not enough electricity flows through. So one question you might ask is how much electricity is enough? Well, that depends on the type of transistor. So each transistor is different. So some transistors have different threshold voltages. So like for example, if an engineer uses a transistor with a threshold voltage of 4.5 volts, then any voltage of 4.5 volts or higher turns on the transistor.
Beshoy, can you come back? Come back a little bit. That's it.
So any voltage of 4.5 or higher turns the transistor on, and any voltage lower will keep the transistor off. Because remember, on and off, because computers only understand zeros and ones. I saw volts as going in. This thing's a transistor. And so what happens is 5.5 volts goes in, and then it's greater than 4.5, so it turns on. It's at 4.5, so it turns on. If it's less than 4.5, this still has electricity running through it, but it's not enough electricity to turn the transistor on. And then like this one is another example, right? So if like you have a mouse that's outputting a certain amount of voltage, the transistor will turn on or off depending on how much voltage that is.
I'm confused.
So let me explain. What are you
just
confused
messed up my entire head.
What are you confused about?
Like, how do you know how many volts are in a thing?
Oh, it's just that's another lesson. I think that y'all want that to be the next lesson.
I mean, I don't care, but okay.
It just if it's a certain amount of volts, it picks up like you need so much energy. If it has enough energy, then it turns on. If it doesn't have enough energy, then it doesn't turn on.
But how do you know if you don't have enough energy and if you do have enough energy?
That's like a 30-minute lecture.
Okay, cool.
But it's gonna be I'm gonna do that next time. So to explain how a transistor works. So let's review before we go
I didn't understand. One more time.
Alright, let's review quickly before we go on to binary. Alright, so you'll know what a transistor is? Okay. So what is a transistor? In 1947, engineers invented the transistor, which is a tiny physical device, right? That acts like a digital switch in computers. It turns on if enough electricity flows through it, and it turns off, it stays off if not enough electricity goes through. Because remember, computers can only understand zeros and ones, on and off, right? But then like you can put so much energy. Basically a transistor limits the amount of energy. And then but then the threshold voltage is the voltage that the engineer programs into a transistor that tells it how many volts is high enough for it to count as a 1. And if it's not high enough, then it doesn't count. So like here's an example. So like 5.5 volts, right, is high enough to turn this transistor on. And then 4.5 volts is high enough to turn this transistor on. But then a tenth, like 1.1 volts That's not enough energy to turn the transistor on.
Mhm.
And then 0 volts is obviously not enough energy. Like this one, you see 3.5 can turn this transistor on.
Mhm.
Yeah. And then these are examples of how transistors look in actual computers. Actually, what's your question?
So they put those little tiny things in a computer.
Yes.
How?
What do you
Like-
mean how? That's what sits on the motherboard.
I know, but like, how is it like connected to the motherboard?
You see those 3 wires, right?
Yeah.
You attach one wire in and then the other one's out. And I think you feed the other one back in.
So is there 2 or 1?
There's 3 of them. Because you have to feed, it's a double feedback loop. That's how it does, how it figures out how much voltage is it.
I thought there was only 1.
Alright, so everybody clear on transistors?
I thought I had a wire too.
I mean,
a
you can, no, the
big
transistor
one.
doesn't necessarily have a wire. But you connect wires to the transistor.
Mhm.
And then it yeah. Everybody good on transistors? Any more questions on transistors? Before we move on to counting and binary?
Or
Transistors are pretty hard. This is super simplified.
understanding.
Mm.
Understanding.
Alright, counting and binary should be easy.
Okay, go ahead.
Alright, so what is binary? Who remembers what binary is? Y'all remember what binary is from last lesson, right?
It's like 1s and 0s.
Yeah. Okay. Do you know how to count in binary?
No.
Okay.
0, 1.
We're gonna count in binary. Okay, so binary is a number system that uses 0s and 1s, bits. Good job. And how do you think we count in binary? How do we count in general? Anybody know how to count?
Yeah.
Count.
They learned it in kindergarten. 1 to what?
Count from 0 to 10.
Okay, I'm gonna count to 500. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
No, stop.
This is decimal system.
Count from 0 to 10.
1, 2, 3.
I said from 0 to
Okay.
10.
0, 1, 2, 3, 4, 5, 6,
0 to
7, 8,
9.
9, 10, 11, 12, 13, 14, 15.
Slowly, bro.
0, 1,
Uh-huh.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Alright,
12.
stop.
10. That's it.
Now look at this. So we have.
Look at 10.
So you got this thing called what you just counted in is called decimal, right? So you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we go to 9, we've run out of digits. So we gotta regroup. So we regroup after 9. So
You
9
see 10?
becomes 10, 1, and then a 0. So just the place value. Alright, so when do you think we regroup in binary?
I mean,
Because remember, binary has 2 digits, 0 and 1.
0, 1.
So when do we regroup in binary?
0, 1.
Yeah, there you go.
1, 0.
Yeah,
1, 1.
yeah, there we go.
0, 1. 1, 1, 0.
No, 1, 0, 0.
Sorry, 1, 1, 0, 0.
1,
1, 0. Yeah, it needs to written.
And then 3. So now let's look at counting in binary. So you start with 0, right? And then you have 1. And then you need to regroup. So it's 1, 0.
Look at the last line.
And then
1,
you need
0.
1,
1, 1.
And then you regroup again. It becomes 1, 0, 0. And then you add a 1. So 1, 0, 1. And then you regroup. 1, 1, 1. And then you regroup.
1, 0, 0, 0.
1, 0, 0.
1, 0, 0, 1.
And then 1, 0, 1, 0.
0.
I'm confused again because you said it was only zeros.
Because you don't understand the decimal.
No, I don't. That's why I'm asking.
Alright, so we count in decimal, Georgie. 0,
Okay.
1,
Mhm.
2,
Mhm.
3,
Mhm.
4,
Mhm.
5,
Mhm.
6, 7, 8, 9, right?
Okay.
And then we run out of digits after 9. So we regroup. Do you know how to regroup?
Yes. Yes.
So it becomes 1 and then 0.
Yeah. So.
What is the highest digit in decimal system?
It's a 9. What's the highest digit in decimal?
What is the highest digit?
Like,
9.
It's a 9, man. So we regroup at the 10th one.
Look at the highest digit is 9.
Nah, here. I'm gonna explain it to you, George. So notice how we regroup after 9, right?
Yep.
So in binary, when do you think we regroup? Because
After
remember,
9.
No, in binary there's no such thing as 9.
1?
Yeah, so we regroup after 1. So 0, 1, and then we regroup.
So it's 11.
No.
I mean 10.
Yeah, 0, 1, 10, and then what do? We add a 1. So 11, and then we regroup.
So that's... Oh, that makes a lot of sense.
So it's 1. So you have 0.
Understand? Mina doesn't understand.
You want me to explain it again?
It's okay, you're gonna understand next.
So 0, 1, 0,
Let me tell you, this is
and
hard.
then you get 10, and then 11, and then 100, and then 101, 111.
We can't say 100. We
Oh,
say
yes,
1,
0,
0, 1, 1,
Yeah, 1.
0, 1.
Yeah. So you got. Y'all understand this, or you want me to go over it again?
We understand.
Okay. See how well. Okay, so here's a good explanation. So in decimal system, right? This is the way we normally count.
Okay.
Y'all know place value, right? You know place
We
value?
have ones, tens, hundreds, thousands, 10,000.
Yeah. So we got ones, tens, hundreds, thousands, 10,000s, and so on.
Millions,
So notice something about the place values. What's the first place value?
1.
Ones. What's 1? You can think of 1 as 10 to the 0. And then what's the second place value?
10.
Tens. What's tens? 10 to
10.
the first power. And then what's the third place value?
10 to the second power?
So you see you're making sense. So now it's ones, or 10 to the zeros, and then 10, which is 10 to the first, and then 100, which is 10 to the second, right? And then as we keep going,
we took powers in school. So.
yeah. So as you keep going this way, so ones, tens, hundreds, thousands, 10,000s, and so on. In binary, we have the same kind of system.
6, 8, 4, 2s, and 1. What?
Because in binary, remember, because in binary, each place value represents something different. So in decimal, each place value is a power of 10. So ones, tens, hundreds, thousands. In binary, each place value, what do you think is the power going to be?
2.
2.
Yeah, so you got the ones, twos, then the fours.
Oh, so you just keep on adding. So you get 1, and you add those, and then you get your answer, and you add those, and then you get your answer, and you add those, and then you get your answer, and you add those.
Yes, you understand.
And so on, and so on, and so on, and so on.
Yeah.
And you get till you get to like 1,074,000.
So yeah, so if you have ones, so like here we have a 1 in the ones place, and a 1 in the eights place. So 1 plus 8. 1 plus 8 is 9, so this is 9 in binary. You see that?
That is 9.
Yes. Because it's a 1 in the ones place, and then a 1 in the eights place.
Oh.
Alright, and then here we have a 1 in the ones place, and a 1 in the 16ths place. So this is 17.
Oh. Okay.
And then here we have a 1 in the eights place, so this is 8. Yeah. And then here, this will
Scroll
go
down.
we have a 1 in the fours place, so it's a 4. So y'all are starting to get it now?
Yeah. It's like this is easy, but you just gotta look.
Yeah.
Go.
Alright. Y'all think you can play Kahoot on this?
No. But we can try.
Alright.
I'm gonna
Kahoot
win though.
isn't- Y'all ready to play Kahoot?
Yep.
Alright. I feel like y'all are gonna fail the Kahoot pretty badly. Because the Kahoot... I mean, don't worry about failing the Kahoot. The Kahoot is a bit harder than... I mean, yeah. It's a bit
Okay.
harder.
Buy my
This is a hard lesson.
Well, not done.
I don't understand.
Really?
Listen to drums.
You used to
Listen
teach
to
this.
You understand it?
No.
It's not a hard lesson. It's an action I'm in.
Processing video. Dang, this thing is still not open.
Let's
You have
go
yours?
over it again before
You
y'all
have yours?
try to play the Kahoot. I feel like this
You
part
have
is
yours?
the thing that's gonna help y'all explain.
You have a phone?
Mina, you understand this part? The place value?
Yes.
So you understand the binary place value? Good. Let's see who gets the highest score on the Kahoot.
Me.
Give us time.
It's 240 seconds.
Just a second. What we gonna do?
Alright, all ready for the kid? I feel like. Also, so important things to remember. Should probably tell y'all. Important things to remember. Alright, so some important things to remember when playing the Kahoot. A bit represents a 0 or a 1. And some of these questions are really hard in the Kahoot. I just want to see if y'all actually understood the lesson. Make sure y'all have fun and try your best. Because I know y'all are going to screw up. Alright, y'all ready?
Yep.
Y'all sure you're ready? Or you want me to go over it one more time before y'all try to play this Kahoot? You want me to go over it?
Yes, go over it.
Okay. So, y'all get this place value thing? Or do you want me to go over it from the beginning? Or I'll go over from right here. So we regroup after 1. And then this place value we have 1s, 2s, 4s, 8s, 16s, 32s, and 64s.
Full screen. I need this one full screen. Can you?
And 64s. You want me to go full screen?
Yes, sir.
Are you good?
Yes.
So we got 1s, 2s, 4s. Remember, everyone know their powers of 2? You know your powers of 2, Mina? You know your powers of 2, George?
Yeah.
What's the powers of 2?
Like 2, 4. Oh, like 10.
No.
Like
2
10
to
to
the
the power
first.
2.
No. 2.
Hmm?
What's 2 to the first power?
What?
You don't know your powers of 2? You know powers of 2?
2, 4, 8.
16, yeah.
2, 4, 8, 16, 32.
64.
Oh, sorry. 2, 4,
Yeah.
8, 16.
Oh, they're just counting by 2?
No. It's 1s. 2 to the 0 is 1s.
1, 2, 4, 8, 16, 64,
16, 32,
32,
64,
64,
128.
1.
And then 256, that's going to be important in the Kahoot, so make sure y'all know. 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128, and 256.
And 1,000.
And then 1024.
1024, yeah.
That's too big, bro. Alright, let's see how well y'all do. I have a feeling like y'all should do okay. Alright, let's switch over to this. Why is the music not playing?
What's the number? 85 05 27
Yeah.
5.
This is super hard. This Kahoot's a little too hard for y'all.
1, 2, 3, 4. What type of game is 1, 2, 3, 4?
Where?
8, 5, 0,
850527
5, 2, 7, 5.
5. What is your name?
Nickname.
Huh? من عايز واحد من
He
هنا
uses iPad. Mine is out of George.
مين what is
Just give me,
Just go get your iPad.
you know. Go get
Just
some.
go get your iPad. Bang. Bang.
You good, Nick?
Kashoot. Okay, I'm gonna kashoot myself now. Okay.
بنك مين بنك ده who's بنك
Me.
you
Yeah.
how many questions
It is 10 questions.
it is 10 hard questions
Super hard question.
no it is not
I mean,
I'm gonna pass the test
you know,
I think
I feel like
Wow.
I would fail this test. I could probably practice this. I put it on the maximum time, so if y'all fail, it's okay.
We're gonna try.
Yeah.
Bro, get it.
Wow.
Are y'all ready?
Today we got transistors.
No, this test doesn't have transistors. But transistors was like a footnote lesson. This test is just converting binary to decimal and decimal to binary.
Oh, converting
So it's
binary to decimal?
Yeah,
Okay.
it's the easier part of the lesson because transistor was rude.
You know, transistor is a good lesson, but need more example.
Yeah, I'm gonna do another lesson on transistors.
Yeah, transistor need more lessons. And binary need more lessons.
Really?
Yeah, if you need to know how can you add numbers, how can you
But that's not.
transfer from binary to decimal, from decimal to binary.
No, this lesson can
Hey,
contain.
go ahead.
Y'all ready?
Yes, sir.
Y'all ready?
Yep.
Sure.
Yep. Who's high?
Alright, let's see how well y'all do.
I'm going to fail.
Okay, so what's this number in decimal?
What is it?
Anybody know what this number is in decimal? Alright, let's look at this.
No, we didn't see the number.
It's in binary.
Huh?
You got a
I'm
binary
guessing
number, and they want you to convert it to decimal.
I'm guessing option 3.
So it's 1s, 2s, 4s, 8s, 16s,
Sixes. How many?
32, 64,
Huh?
128.
64 plus 128. تطلع كام؟
Don't give him the answer.
128, 64, 192.
So put one up.
Yeah, I'm right.
Yes, let's go. I'm in first place.
Y'all are smart.
I'm
Yeah.
in first
Good
place.
job.
Count
I'm
then,
first
because I can't see the screen.
I guessed that I'm first.
I was this number into decimal.
What's it? Count. How many?
0, 0, 0.
No.
Got ones,
Yes.
2s,
3,
4s,
7,
8s,
16. 16 plus 7.
Oh
23.
shit! I accidentally put it in.
There's no 16.
I accidentally put in 13.
1s, 2s, 4s, 8s.
I accidentally put in
1
13.
plus 2 is 3 plus 4 is
1, 2,
I
3,
put in the wrong answer. I'm in
4,
last place.
7,
No.
8, 15. 15 يا bro. 15 يا bro.
You're right. Please make me
Yeah.
accidentally put.
15, 15.
Accidentally.
everybody clicked it
No.
up?
Yeah,
I
15.
clicked
Who
13.
put? You clicked 13? Okay. Who put blue?
That is in first place.
You put blue, Mina? Why'd you put blue? That's okay.
It's
That-
hard.
Alright, I know how to.
I think these should get easier.
Hmm?
Damn it!
Alright, no. Alright, so you got this number. 0,
Okay.
1.
Count.
Let's go through it. Ones. There's
0, that's 3. Huh?
2s, 4s, 8s, 16s, 32s, 64s.
64 plus 16.
Plus
Plus 3. Plus 3.
Yeah.
64 plus 3, 67. 67 يا bro.
Let's go!
bro.
Damn.
Yep.
Good
Yay!
job. Y'all are getting this.
I know how to fit these
The
answers.
problem I
now.
can't see
I,
how
look, this way is the opposite.
If
Convert
Jesus loves
2,000 in binary.
200.
200 in binary.
What?
What the hell?
Oh!
What the
Oh.
hell?
Conv-
So we
I'm
got
praying to the Lord
ones,
Jesus.
2s, 4s, 8s, 16s.
No. We're gonna divide it by 2, divided by 2.
You can do it that way.
100, 50, 25,
Yeah, I'm close.
30. That's right.
Ones, 2s,
The blue one.
Yay, I'm right again.
The blue one.
128.
The blue one.
64.
Yeah.
Whoa,
Wrong,
we all got it wrong.
Wrong.
We all got it
Alright, so
wrong.
let's see how they do this. Okay. So you got ones place, then the twos place, then the fours place, no digits so far.
Look,
Then 8,
200.
200
0,
minus
0. No, divided by 2, 100. Divided by 2, 50.
you can do it
Divided
that way,
by 2, 25. All of them zeros.
but you can do. There's an easier way to do it.
How?
Divided by
You
2,
could just subtract.
we're gonna put
guys.
1
I'm gonna record
and
this.
12. 12 divided by 2, 6, 0.
That way is much harder to.
Yeah.
You could do.
So,
You could do 128. So we got a ones in the.
yeah, the orange one. The brown one.
It's not brown. I have a color blind. It's orange.
You could put a one. So we got a ones 28. So ones, twos, fours, 8. So there's an 8, right? And then 16, 32. 8 plus 64
Yes.
is.
This is the brown. This is the right one.
72. 72 plus 128. Yeah, that's right. Or you can subtract 128, and then you have 72.
The 2. Yeah, because it needs a piece of paper.
I think this one's the hardest.
Yeah, do it.
That is
Yeah, now 44 in binary.
Okay,
44 should be.
it is easy. 44 divided by 2, 22, 0. Divided by 2, 11, 0.
44.
Divided by 2, 1, 0, 0, 1.
Twos.
Divided by 2, 0.
These are 8.
Divided by 2,
64. Also.
there is a 1. I don't know. Maybe
30 is red.
the blue. I can see the red.
It's 0010.
Thank you for giving me the answer.
I think it's red.
The red one. Need a piece of paper.
No,
Yeah, that's
okay,
right.
so it is the red one. So what you can do is you 8 digits in binary is 128. So you know 128 is too big for 44. So it's 128, then 64, and then 32. And this is the only one that like has. This one's too big, because you know this one has a 1 in the 64th place, which is too
We're
big.
gonna divide it by 2. It is easier. 44 divided by 2, 0.
Okay.
I have a pattern.
Divided by 2,
Oh, okay. Remainder method.
11.
I noticed a
0.
pattern.
Divided by 2, 1.
Mhm.
The third place 1. The third place 1.
Okay.
Look.
Oh,
10 divided by 2, 11. 5 and 1.
Yeah.
That's right.
Okay. So it's like you divide by 2 and take the remainder.
Yeah, 4
That method
divided by
works
2,
too.
0. 0.
Yeah.
Divided 1 divided by 2 is 1.
Okay.
So the red one is right.
Okay. Well, what pattern did you notice, George?
I noticed that it's the third largest number that's always correct.
What do you mean?
It's hard to understand.
Alright, let's see how well y'all do. Okay, this one is binary and decimal, so this should be easy. Okay.
What?
Twos, or ones, twos, fours,
1
plus 2,
plus 2, 3 plus
fours, 8,
8.
plus 3 plus 8.
No.
That's right.
3 plus 8, 11
Yeah.
plus 16.
There's not a.
Why do you need to go to 16?
16 is a 0.
A 0. But which
I
one?
got it right,
3 plus
boys.
3 plus 11.
Yeah.
The brown
George,
one.
you got a big brain.
I'm big brain. See, I
Relax,
told you it's
relax.
always the third largest number.
Yes.
Probably a. Alright, let's convert 100 into binary.
Oh shit.
Like the decimal 100.
Okay. 100 to binary.
By 2. Yeah.
Divided by 2,
Is 0.
50.
Wait,
0.
shit.
Divided by 2, 25. 0. Divided by 2, 12. 1.
Uh-huh.
0, 0, 1. Divided by 12. Divided by 2, 6. 0. Divided by 2, 3. 0.
Uh-huh.
Divided by 2,
Then
1.
why he was doing
Divided by 2, 0, 1.
Yeah.
What is it?
This one probably.
No.
I don't know, the red one or the brown one.
It's the brown.
I got red.
Well, no, they're not the same.
10.
Okay.
10.
Divide by 2, it's 50.
50.
Divide by 2, it's
25
And
divided by 2, 1.
It's yeah. 1.
12 divided by 2, 6, 0. Divided by 2, 3, 0. Divided by 2, 1. That meaning 0, 0, 1, 0, 0, 1.
Yeah.
Which one?
The
The brown?
brown one.
The brown one.
Good job. Oh wow.
Wrong. Wrong.
Everyone got it
That
wrong.
method
It was
doesn't
blue.
I don't think that method works. Oh, that method works the other way.
Oh shit.
That method works the other way.
No.
Yes, it does. That's why we're getting it wrong. Because I remember reading this method. The method works the other
Give
way.
me a paper. I need a paper.
No, I think don't turn it off. Did you turn it off?
No.
The method works the other way. So you were right.
Look, after you finish, this way. After you finish, in your right hand.
Oh, that's
Give
right.
me a
Yeah,
visit.
we see it's left, right. You're right.
George, give me this paper.
Yeah, you're right. It is from
Yeah.
the right hand. So it's 001 00110, which is
Yeah,
this
the
one.
blue one, that's right.
But
But
we put-
I asked it because I can't see it. Okay.
But then the other way,
Need another
this
pen.
one's backwards.
How many questions
the
do we
bin.
have left?
I need a pen, yeah, George.
That is a pen.
No.
Just use it.
Alright, we
No,
got
that's
2 more
bad.
questions. Convert
Can you
5
give me
into
a
binary, y'all.
Mina, can you give me
Alright,
a
come
bit?
on, y'all. 5 into binary.
What?
5. 0.
Yo, these binary
That's a
questions.
Huh? Which one?
5. Number 5 into binary.
5.
It's gonna
You
be
need to
one.
convert the 5 into the binary?
Mhm.
5. Okay.
This one.
5 divided by 2 is 2.
Remember, this is 1s, 2s.
1 divided by 2.
This is 1s, 2s, 4s. Do you pick an answer, George?
2 is 1. 101.
Yeah.
What is it?
Which one's 1, 0?
Ah, the green one.
Yeah.
Let's go. I got it right.
Just a
buddy.
second. The green one.
Stop shutting up, man.
Yes, sir.
Good job. Alright,
Whoop.
convert 20 into binary.
Okay.
Dang, we don't
20 to the binary, right?
Yep.
Divided by 2.
0.
Oh,
Just
you're so
10.
annoying.
Divided by 2 is 5. Divided by 2 is 2. Divided by 2 is 1. Divided by 2 is 1. 0, 0, 1, 0, 1. 0, 0, 0, 1, 0, 1. The green one.
Okay.
Yep.
Good job.
If I have a piece of paper, I can count.
Alright, last one.
Okay.
Alright, this one into decimal, y'all.
I'm
Okay.
in last place.
See it. Read it.
0, 0, 1s, 2s, 4s, 8s, 16s, 32.
How many zero? How many zeros before
There's
one?
a 1 in the 32's place.
Huh? 0, 0. This is 4?
Yeah.
Is it one?
It's 5 zeros.
Okay.
It's 1s, 2s, 4s,
2.
8s, 16s,
Okay.
32.
So 2, 4,
Stretch.
What you
8,
put?
I accidentally
16,
put 50. I meant to click 64.
32.
Where do you see 64? 1s, 2s, 4s,
Okay.
8s, 16s, 32s.
I know. it's
Son,
64.
relax.
Why'd you mean to click
6.
64?
6.
Oh.
6
oh,
plus
okay,
8,
then I'm right.
14. 14,
What are you doing?
30. 62.
No.
64.
Wait. That 5 0? 1s, 2s, 4s, 8s, 16s, 32.
How many, what's the brown?
Brown is 64.
Yes, that's right.
You have like 5 minutes to finish it.
Red, my
Wrong.
guy. Why'd you put 64?
I don't know.
Mina, you got it right. Cause
He probably won first place.
Minutes the first place.
nah, it's high. Who's high? Oh, that's me. Good job.
Minutes the first place. Good job,
Yeah.
Yamin.
Good job, Mina. But you and Daddy got the same number of questions right. Alright, so y'all enjoy the lesson? Is this
No, that's it.
You
It's
said
hard because it is need another
It needs a couple.
Yeah.
I think. So y'all want to do? I wanted to ask y'all a question. Do y'all want to do binary next time? Or do y'all
No.
want to do transistors?
What the hell is transistors?
Because
We're gonna get the transistor.
Let's finish binary and then do transistors.
Because they're both in the same, like, transistors is a footnote. It's a 30-minute video. That's really hard to understand.
Okay, let's not do that.
No, because transistors, are y'all interested in how transistors work?
No, not really. I am interested, but it takes forever.
It's a 26-minute video.
That's hard.
And then I'll explain it. But it involves a lot of electric.
No, you can give us some example how to convert it between binary and decimal, but a little number, like what, 2, 4, 6, something like that. Okay.
You want to do that next time?
See you next time.
See ya.